Welcome back. This is an Aleks homework video on deducing the ions in a binary ionic compound from its empirical formula. So, if you're given a formula like NaCl or AuI3, you need to know what ions make up that compound. Well, the compound tells you the combination. So the formula or the recipe of NaCl is 1 Na and 1 Cl. Well, what are the charges? You already know that if there are no subscripts, so it's not Na2 or Na3, it's just Na and Cl, meaning 1 and 1. If you know that that's 1 to 1, you already know that it's the same charge. So Na is going to have the same charge as Cl. The periodic table is the most helpful to know this. Always have a periodic table when you're doing a problem like this. You should have it out all the time. So the periodic table tells you what the column of on the periodic table that it sits in, and the column usually tells you what's the charge. All right. So if you have a representative element, which is the first two groups and the last six groups, you can easily guess its charge. Right. The way it goes is from the beginning, from the first column, it will be positive 1. The second column, positive 2. The third column, positive 3. The fourth column, which is carbon, usually you're not going to see a lot of ions from that column. It does chemistry a little bit differently. It doesn't really steal very much. A lot of times it'll share some other way. But you will have either positive 4 or negative 4. Once you get past column 4, you're going to start, it's getting closer to remember, everything wants to be like group 8. It wants to have a valence shell filled just like the noble gases do. So it's easier to steal than it is to give away. Positives are, remember, giving away. Negatives are being stealing. So if the carbon group is negative 4 or positive 4, then the fifth group, which is the nitrogen group, is going to steal, and it is 3 away from group 8, so it's going to need to steal 3. So anything in the fifth column is going to steal 3. It's going to be negative 3. Anything in the sixth group is going to be negative 2 because it needs 2 to be like the noble gases. Anything in group 7 is going to be negative 1. Let's do that again. Group 1, positive 1. Group 2, positive 2. Group 3, positive 3. The carbon group normally does not make ions. The nitrogen group is negative 3, and then the oxygen group negative 2, fluorine group negative 1. Anything from the transition metals, which is the scandium to zinc valley in the periodic table, you're going to have to figure it out. You can't simply guess it. You're going to have to figure it out based upon what it's matched with. So we'll do some examples here. So let's do sodium chloride. It's done. Sodium is in group 1, so it's going to be positive 1, so you're just going to write Na with a positive 1. Chlorine is in group 7. That means it becomes negative 1, Cl negative 1. All right. Now gold. Gold is in the transition metals, so I don't know. It's not from a column that I can guess. Okay, I can't guess gold, but I can guess iodine. All right, iodine is it's in group 7, so it's going to be negative 1. Well, how many negative 1s do I have here? I've got 3 negative 1s, and this all makes a 0 charge. So once it becomes a compound, it's going to cancel out all the charges, so it's going to be neutral. Well, if this is 3 negative 1s, I'm going to need something to balance it with. I've got 1 gold atom, so it's going to be Au positive 3. It takes 3 positives to balance with 3 negatives. Okay, so if you know it right away, you can do it right away, but if you don't know it, do the nonmetal first, which you can guess, and then figure out the one that's on the other side. Figure out the metal. All right, so this is Fe2O3. Well, iron is a transition metal, so I can't guess it. Because remember, they have multiple oxidation numbers. That can be 2s and 3s and all kinds of different ones. So I can't guess it yet, but I am going to have to figure out the oxygen. Oxygen is in group 6. That's 2 away from group 8. That means to get like group 8, it needs to steal 2. So oxygen is going to be -2. All right? So I can go ahead and do that one. Oxygen is -2. Well, how many -2s do I have? I've got 3 -2s. All right, so that's a total of -6. All right, so that means on the other side, this is equal to +6. Okay, so I've got 2 atoms that together equal +6. Well, how many does each atom do? If I've got 2 of them equaling +6, then I need one of them to be equal to +3. And so I'm going to write Fe 3 plus. Okay, that one's the hardest one so far. You have to maybe back this video up and look at it again. Let's look at the manganese chloride. Manganese is one of the transition metals, so it's going to have a Roman numeral. Okay, you would actually call this gold 3 iodide. You would call this iron 3 oxide. All right, manganese is one of the transition metals, so I can't guess it, but I can go to the chlorine. Chlorine is in group 7, so it's going to be -1. I've got 2 -1s here. That means that that has to balance 2 -1s, so this is Mn +2. And the last one is gold 1 fluoride. See, up here, gold was +3, but here it's going to be something different because fluorine is in group 7. It will steal 1, so it becomes -1. So fluoride is -1. I need 1 to balance this one, so this has to be gold +1. I would call that hard. This is something you're going to have to do repeatedly to understand, but I think once you get it, you'll be far ahead. Thanks.